Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Hafizuddin. So this is the presentation for photo system project. So I am in charge in closed loop system 1. So objective 1, this is mathematical calculation. So here I'm using the formula TS equal to GS 1 plus HS times DS. So after I done this, I will get the answer 1 over s squared plus 1, and I need to find the roots of dominator. So the answer is here, and now I will show you the MATLAB software for plot zero graph. So as you can see here, this is the command window for MATLAB. So first we need to insert the equation, the function. So next is the h. So next we will first PZ map, and then the graph will open here, and we can see plot zero map, and then we need to enter the grid. So as you can see here, the two value that here is 0 plus 1i, and here is 0 minus 1i. So based on the calculation, the plot zero this system is stable, and yeah, we will continue to objective number 2. Here we can see the plot zero map I insert in the the report. So next is objective 2. So here is the installation MATLAB. So I copy here. And then I will open the MATLAB. So we need to clear this. And we paste. Wait for a second. So basically I do by manually. So here we use this, and then h equals to 1. Then the t feedback th. After that we use t, the small t for time, and this is the graph. This is the graph for step response for this system. So next we need the state info. So as we can see, there is no rise time, there is no tracing time, settling time, overshoot, and also undershoot. So the peak and the peak time is infinite. So based on the report here, I show you I also insert the state response graph here, and also I do some explanation here. And as we can see in the table here, the graph is marginally stable, and overshoot there is no overshoot. While steady infinity, steady state is infinity, and steady state area is infinity. So next, for objective 3, I need to just insert the PID controller here, and I insert the KP is equal to 10, KI is equal to 10, and KD is equal also equal to 10. So this is a graph for objective 3, and the overshoot is 9.757 for overshoot. The settling time is 3.8716, and the steady state error is 0. So it shows that when we add a controller, it becomes more stable. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najwan bin Abdul Rahman. My metric number is AA211519. So, I will present about closed loop system 2. For the closed loop system 2 is, the objective one is the question asks that determine the poles and zeros and sketch the pole zero plot for each closed loop system. From this question, uh, we need to write the equation, which is feedback equation, uh, GS over 1 plus GS plus HS. This is for the equation. And from the closed loop system 2, the equation is 20 over S square plus 2S plus 9. From this equation, we can solve it using our mathematical, and the answer we get 20 over S square plus 2S and plus 29. From this uh, equation, we can find x1 and x2 using quadratic formula, which answer x1 is -1 plus 2j and 7i, and while x2 equal to x1 -1 -2j and 7i. By using MATLAB, we declare it as G equal to TF 2129, and we get the answer is 20 over S square plus 2S plus 9. It's the same uh, equation like previously. So to find the feedback, we declare it as T1 equal feedback G and 1, so that we can get 20 over S square plus 2S plus 29. To find the graph, we need to declare the time, and after we declare the time, we show that the step T1 and T, we can get the graph like this by using whole zero map and grid. So we get the graph like this, and to find the rise time, decision time, settling time, we declare it as step info T1. For objective number 2, the question asks that develop the closed loop system using MATLAB Simulink. So we need to use the Simulink to get the graph and to determine the tabulate overshoot, settling time, rise time, and also steady state error. From MATLAB, we click the Simulink button. So we uh, use the Simulink, and we will get like this using the equation. After we have finished decorate it, we get the graph like this. So to find the overshoot, rise time, setting time, and steady state error. Previously, I have uh, used it in objective one, which is the same. So the rise time is 0.224. Setting time is 3.7156. Overshoot is 55.2080, and the steady state error is from the graph is 9.31. So from the graph, we know that the closed loop system 2 is stable. For objective number 3, the question asks that uh, we need to add a PID controller block to the closed loop system. And number 2 is determine which type of controller is needed to meet the design requirement. You may implement P controller or PI controller or PD controller or PID controller that could give the required outcome. So, from my opinion, I use mm, P and D controller. So, from the MATLAB, I declared it G equals TF 21 to 9. So, the answer we will get 20 over s square plus 2s plus 9. For the feedback, also the same from previously, which is T1 feedback, G and 1. So we can get the T1 is 20 over s square plus 2s plus 29. So from this equation, I declare it G3 equal TF 20 and 1 to 9. So the G3 will declare it as 20 over s square plus 2s plus 9. So to declare the PID, I use GC3 equal PID bracket 30, 0, and 30. So the answer I get is GC3 equal to KP plus KD S with Kp equal to 30 and Kd equal to 30. So after that, uh, for the G3 to find the G3, I equal as GC3 sub with G. So G3 I will get 600 S plus 600 over S square plus 2S plus 9. So for the feedback, I declare it as T2, which is T2 equal feedback G3 and 1. So the answer I get 600S plus S over S square plus 602S plus 609. So that's for the transfer function. So I declare the time, and also to find the graph, I declare it step T2 and T. The graph I get is like this. So to find the rise time, setting time, overshoot, I declare the S equal to step info T2. So for the closed loop system 2 is PID controller, I get Kp equal to 30, Ki equal to 0, Kd equal to 30. And overshoot, I get 1.3095, and setting time I get 0.057, and the steady state error I get 0.985. That's all from me for the object for the question closed loop system 2.
Okay. My name is Muhammad Zikri Aziz bin Rosaidi and my matrix number is AA211308. Today, I will present about closed loop system for number 3. Okay. First, for objective 1, the mathematical calculation. So, the calculation is used to determine the false and zero. So, the transfer function given is GS equal to 250 divided by S exponent 2 plus 4S plus 50. So, the feedback formula that we use to get the answer for this mathematical calculation is CS over RS equal to GS divided by 1 plus GS times HS. So next, we insert the GS to the feedback formula. So it will be CS over RS equal to 250 divided by S exponent 2 plus 4S plus 50 divided by 1 plus 250 divided by S exponent 2 plus 4S plus 50. So after we insert the GS to the feedback formula, and then we just we can settle it for 50 plus 250. So after that we will get 300, and the final answer is we got from the calculator. Uh, okay, next, I use PZ map instruction to do the pole zero plot. So this is the transfer function that I got. Okay, next, based on my result in 1 and 2, the system is stable because when the poles of the system are located in the left half plane, the system is shown to be stable. Okay. Next, for objective number 2. After I developed the closed loop system shown in table 1 using MATLAB Simulink and run it, the step response shown is as in here. Okay. Next, the characteristic of original closed loop control system. First, it is stable. The overshoot that we get is 69.4%. Next, the rise time that we got is 0.0659. And next, the settling time is 1.8667, and last, the steady state error is 0.169. Okay. Next, objective number 3. For objective number 3, I add the controller to the closed loop. The type of the controller that I implement to give the required outcome is PID controller. So this is the step response after I run the simulation. Okay, and last, this is my new values for overshoot for objective number 3. For the overshoot for closed loop system number 3 is I got 1.6%. Next, the settling time I got 0.0131. Next, the rise time 0.0082, and last, the steady state error is 1%. So that's all from me for closed loop system number 3. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Zulhaika bin Zulkifli. My metric number AA212047. And for this project, I will do block diagram number 4. This is block diagram number 4. Okay, for objective 1, show mathematical calculation using characteristic equation to determine the poles and zeros and sketch the pole zero plot for each closed loop system shown in table 1. Okay. From this block diagram, we know that GS is uh, 250 over S to the power of 2 plus 4S plus 50. For HS is 2 over S plus 2. For the formula, I use formula TS equal to GS over 1 plus GS HS. So after uh, after substitute all uh, all the value for GS and HS into this formula, the final answer I get is 250S plus 500 over S to the power of 3 plus 6S to the power of 2 plus 58S plus 600. Okay, after this after this final equation, I will check my answer by using MATLAB. Okay, first uh, G. Okay, to check my answer in MATLAB, first G G equal to TF. Okay, to check my answer with that calculation, I using MATLAB. Okay, first of all, GTF, then this equal to feedback. So this is the same final answer with my calculation. This okay. Okay, for the poles and zero, the zero is uh, 250s plus 500. This is zero, and below is poles. For zero, s equal to minus 2, and for the pole, there are three. First of all, uh, negative 8.05 plus 0j. Okay, second, 1.02 plus 8.57j, and lastly 1.02 minus 8.57j. Okay, I already draw the diagram, this, and then for to check my answer, return to MATLAB and search and type pzmat t. Okay, this is the graph, and then grid. Okay, okay, from this graph, it's same with uh, with the drawing I made, and then uh, this from this graph, we know that this system is unstable because there are two X mark that are at the right side of the graph. Okay. Okay, for the objective 2, develop the closed loop system shown in table 1 using MATLAB Simulink. Okay, first of all, we create uh, we create this block diagram in Simulink. Okay, after that, we input the value. Same with this: step time 0, initial value 0, final value 1, sample time 0. Then click OK. Okay, after we input that value, click run. Okay, and then the result will click here for the result at the scope. Okay, this is for the graph. Okay, and then after we get this is the result for the state response. Then next, for the stable closed loop system, determine whether it is under damped or over damped or critically damped. As we know, this block diagram number 4 is unstable closed loop system, so they are not have under damped and all. Next, determine the tabulate the uh, overshoot percent, settling time, rise time, and steady state error. Okay, to know about that, first using same. Okay, for the value, first determine the tabulate, overshoot, settling time, rise time, and steady state error. Okay, first we use the same command from objective 1, and then we just plus uh, step info t. Okay, because of our closed loop system is unstable, the overshoot, rise time, settling time, and all is none. None is not a number, so the value is infinity for all. Overshoot is infinity, settling time infinity, rise time infinity, and steady state error is infinity. Because of the unstable closed loop system, all of the result for the overshoot and all is infinity. Okay, for objective 3, add a controller to the closed loop system in order to meet the design requirement. This is the design requirement for overshoot, settling time, and steady state error. Okay, for block diagram number 4, I choose PID controller because PID controller can meet the design requirement for overshoot, settling time, and steady state error. First of all, we should declare G H, and then we also need to declare PID controller. Okay, first declare G and then declare H. Okay, next I will declare the controller. I will declare PID controller K equal for K, and then after that I will declare G1 for the transfer function. Okay, K multiplied by G. Okay, then we'll make feedback. The feedback G1 G1 is K multiplied by G. Okay, feedback. After that, I will declare time. Okay, and then step T for the result. Step T. The step T, step info T. Okay, this is the graph that I get. Okay, first of all, peak response. Peak response is overshoot. We get under 10%. That is 0.0007. Okay, after that, for the settling time, I get 4.85 second, and then steady state, the final value is 1. So the steady state error is 0%. Okay, next, record the step response and tabulate the new values for overshoot, settling time, rise time, and steady state error. Okay, for this, we just use step info T. Okay, I already have used step info T. Okay, this is for the rise time, settling time, overshoot, and and so on. Okay, that's all from me. Thank you.